Hi ladies, this is lesson 6.4, and in this lesson we're finding inverse functions. So we've got a couple definitions. The first one is inverse relation, and in an inverse relation we switch the input and output values of the original relation. So that's your x and your y values. And the second vocab term is inverse function. And an inverse relation is an inverse function if the inverse relation and the original relation are functions. And remember the difference between a relation and a function. A function has to have, for every x value, or for every input, there is exactly one output. So as we graph a function, we use the vertical line test to determine whether or not it's a function. But just looking at a correlation, you're looking for any x value that maps to only one y value. So let's look at this first example. And in this first example, we're finding an inverse relation. So we're finding an equation for the inverse of the relation y equals 7x minus 4. And when we're finding an inverse relation, we're switching the x and the y values. So here we have y equals 7x minus 4, and we're going to rewrite that as an inverse, switching the x and y values, and then we're going to solve for y so that it's in standard form like this. So x equals 7y minus 4. So that's our inverse relation. We're switching the input and the outputs. We're switching our x and y. And now we need to put this in standard form in order to solve y for y equals something. So to do that, we're going to add 4 to each side. And that gives us x plus 4 equals 7y. And then we're going to divide both sides by 7. And then we have y equals x plus 4 over 7. So when we're thinking about the inverse relation compared to the original relation, we can set up a table like you would when you're solving for, or when you're getting ready to graph something. So our x is our independent variable in our original equation, and y is our dependent variable. So if we have these x values, -2, -1, 0, 1, and 2, and we use this function, we use this relation, y equals 7x minus 4. And we substitute those x values in. When x is -2, y is -18. When x is -1, y is -11. When x is 0, y is -4. When x is 1, y is 3. And lastly, when x is 2, y is 10. Using this relation, 7x minus 4. Now in the inverse relation, what we're doing is we're switching the x and the y values. So in an inverse function, we have our x, we have our y, but our x value from our original is now our y value. And our y value from our original is now our x value. So we can rewrite our table just by switching the x and y values. -4 and 0, 3 and 1, and 10 and 2. Okay, so what was our y values in our original function? original relation is now our x values in our inverse relation. So if we look at this relation that we just found, y equals x plus 4 divided by 7, that will hold true with these x and y values. So let's try just a couple so that you can see how switching the x and y values in the relation equation and in the relation table hold true in both circumstances. So -2, we're just going to look at y as -2. -2 equals -18 plus 4 divided by 7. So -2 is -18 plus 4, which is -14 divided by 7, which is -2. So that will work with any of those x and y values in that table using that inverse relation that we just found. So in the last lesson, we looked at compositions of functions. And in this definition of inverse functions, we're looking at the function g composed with f and the function f composed with g, or f of g and g of x. So functions f and g are inverses of each other if g composed with f equals x and f and g composed with f is also x. So if f of g is x and g of f is also x, then those are inverses of each other. So g is denoted by f -1, which is read as the inverse of f, or x inverse. So let's look at this property now, and we're going to verify that these functions are indeed inverses of each other. So first thing we need to do, we need to show that f of -1 of x is equal to x. And we're doing this because g, that's f of g, g is denoted as the inverse of f. Okay, so step 1, let's show that that's true. So we need to do the composition of g and f, so g composed with f. So that's 7 times the inverse, which is 1/7 x plus 4/7. Minus 4. This 1/7 x plus 4/7 replaces this x here. Okay, so this whole function is replacing our independent variable in f of x. So when we solve this, we have 7/7x plus 28/7 minus 4. That's our distributive property. 7/7x, which is just x. Let's go x again. All right, 7/7 times x, which is x plus 4 minus 4. That cancels out. This is 4. 28/7 is 4 minus 4. So we want to show that that's equal to x. And in this case, yes, x equals x. That's true. Then our second step is to show that the inverse of f or g of f of x equals x. So we're going to do it both ways. We're going to do both compositions. Okay, so in this case, we have 1/7, 7x minus 4 plus 4/7. So this 7x minus 4, and I'll use a different color highlighter here. This 7x minus 4 is replacing this x, and that's our f of x. Okay, so we're using compositions here. So 1/7 times 7x using the distributive property is 7x over 7 minus 4 over 7 plus 4 over 7, and we want to show that's equal to x. So we're saying x minus 4/7 plus 4/7 equals x, which is true. X equals x. So with these two, f of the inverse of f of x equal to f, and the inverse of f equals x, so if those are both true, then yes, these are inverses of each other. So try the second one on your own. You can pause the video while you work. Follow the same steps that we did in the last one, where you're using your compositions in both directions. So the composition of the inverse of f and the composition of f and the inverse. So here are step 1 and step 2, if you needed a little bit of guidance to begin. So then you'll solve for both of those compositions, and they should both be equal to x, if they are indeed inverses. So before we can verify that they're inverses, we need to find the inverse first, and to do that, we're going to switch our x's and our y's. So first we found our inverse of x minus 5 divided by -3 is y, and now we need to verify that that is the inverse of f of x. So first we'll show that f of the inverse of f of x is equal to x, which it is. And now secondly, we're going to do the composition the opposite way. So f of x composed with the inverse. So then our second step, showing that f of x composed with the inverse of f is equal to x, that is also true. So yes, we found the inverse. The inverse is y equals x minus 5 over -3. And we verified that it was the inverse by doing both compositions, f of the inverse, f composed with the inverse, and the inverse composed with f. So in the follow-up video for this lesson, we're going to look at graphing and defining whether or not inverse relations are functions. So this concludes part 1, but tune in for part 2. And please jot down any questions you have. Thanks.